All right, so this is section 2.3, where we're going to look at misleading graphs or misrepresentations of data. So this section is going to talk about bad graphs. What makes a graph good versus bad? And then we're going to look at some examples of bad graphs and how we can make them better. So this is a famous phrase. Statistics, the only science that enables different experts using the same figures to draw different conclusions, by Evan Issar. So what happens is people can make graphs misleading. And they're misleading if they unintentionally or sometimes intentionally create an incorrect impression. So it's misleading if it's unintentional. The graph is deceptive if it is intentionally made in a specific way to draw your eyes to a specific part of the graph. Okay, so sometimes a graph is just made bad by a mistake, something you didn't even know. Then there's other times where it's actually made specifically in a way that draws your attention to something else. Okay, both of which are bad. It's never good to look at an incorrect, misleading, or deceptive graph. So that can hinder or make graphs look bad.
Okay, so the way that most commonly graphs are misleading is first off the scale of the graph. So that's usually with images on the scale, pictures, an inconsistent scale, which is where you don't count by the same value each time between the tick marks, or a misplaced origin, such as the 00xy is not shown.
So what should happen instead is we should have increments between tick marks should be constant, and the scales for any comparative graph should be the same. So all the scales, if we're counting by 200, should count by 200. Every tick mark should increase by 200, and we should always see our origin or our starting point of 0. If we don't see that start point or that baseline of 0, it skews the results. All right, so here's what I'm going to show you. So this is a bar graph of the number of people in poverty in the United States for different years. Okay, so based on, if I just look at this graph, don't look at anything else, it looks like here it was really low and it's grown so much. Okay, but if I look here, it says this is 30,000 and this is 50,000. Okay, my scale is even, I count by 5,000 each time. This counts by 1,000 each time, so my scale is good, but the fact is there is no 0 here. There is no origin. So what they're doing is they're causing you to see that this looks like it's so much bigger. It's so much compared to 2,000. So here's what I'm going to show you. On the next slide, I'm going to show you a correct representation with 0, and you're going to see that it's not as drastic. There is still a difference, but it may not be as drastic. Okay, now they still put a 0 here, but it's still technically misleading. Okay, it doesn't matter that 0's there or that they put this little break here. It still is beginning at 30, even though it has that 0, this scale now here, this break is a distance of 30,000. So this is still not good. All right. What's going to happen is, again, it makes it seem like this is 2 times as large. We've more than doubled this, because if I, let's see, oh, okay, this looks like 3 times as large. But it's not. Go from 32,000 up to, this isn't even 50,000. So what does that look like? Maybe 48,000. It's not 3 times as high. So again, even if you put a 0 here, if this scale is not even all the way across here, it still is misleading. Okay, So both of these are bad representations because even though this one starts at 30,000, shows it there. Even though this one starts at 0, this gap is not the same as each of these gaps. So it's still not okay. We have to make sure that if we're going to draw that graph, that it is accurate. So 25,000, 20,000, and if your line's going to be down here, and these bars are going to be a lot different in size. You're going to see that they're not as far apart as they were here. Okay, so anytime you're looking at a graph, make sure that 0 is there and that there is no jump like this. Okay, I know we were taught that, like, hey, you can do this when you were maybe in a math class before, but it actually makes our graph not so accurate. So that's why we use our technology here, and we should use that to create some accurate scales here. All right, the next one's going to look at a pie chart and how we can make a pie chart misleading. So again, we're going to look at the misleading exaggerated graph first, and then the non-misleading one. Well, this one, sorry, actually has a non-misleading. We didn't have the exact non-misleading one here. If I had the actual data, I could redraw it so you could see it, but I don't have that raw data here. All right, so both of these were misleading. So let's look at a pie chart. This is going to represent, what did it say here? The educational attainment of residents in the United States, 25 years or older in the year 2017. This was based from the census, and you have to fill out what level of education you have reached. And they have turned these into their relative frequencies so we can create a pie chart. All right, so a pie chart like this is misleading. Okay, we do not like 3D. Three-dimensional graphs skew our information. They are not the same as a flat graph. Okay. Another problem with this 3D is what happens is your eye goes right here to what's right in front of you, rather than seeing the full graph flat from the top and being able to truly see how these pie pieces relate to each other. Okay, so on the next slide, there is actually a correct version of this graph. And that is going to be from a vertical perspective. So if you look here, it looks like this is actually the biggest. Okay. But in actuality, the one that's the biggest is this blue high school diploma. So this doesn't look like the biggest here, but it is actually the biggest. Okay, so a pie chart should always be a top-down view so you can compare your results. You always want to have these percentage values in here so you can compare. There's no percentage values here, so I can't compare to see, but that was done intentionally. Draw to this. Okay, they wanted to draw your attention to something that the graph didn't exactly show. Note to self, when you look at a graph in the news or in an article, make sure you're looking at that graph to see, did they draw this graph correct? Or were they trying to mislead me into believing that it was something else? All right, so ways that you can construct a good graph. Title, label your axes, explanation if needed, give units of measure. Is it in thousands? Are we measuring feet? Are we measuring volume in liters? What are we measuring? Okay, do not distort or lie about your data. Get rid of any white space, extra area. Don't worry about your scales being truncated to make it happen. You want all scales to be accurate. So even scales, origin. Don't add extra spaces or whatever to make it look better or prettier. make the graph accurate. You do not need clutter or a ton of extra grid lines all the way going across here so that as I see it, we can get it. We don't want to have pictures or any background images. We don't want to distract anybody. And we do not want 3 dimensions. Please, please, please do not ever do a 3-dimensional graph. Not a pie chart, not a bar graph, nothing. Please do not use 3 dimensions. They are not accurate. Be simple. Pick one font, use it. You don't have to change fonts or colors or anything like that because that draws attention to different areas of your graph rather than letting the graph just show the data. Okay, and do not do anything that has no scales. You have to have scales. I can't look at a graph and just see, oh, here's this and that, and I've got no information. I don't know what I'm looking at. Okay, always label. Always give me values. Label, give me my values. Okay, always have a scale, always have 0, always have a title, no 3 dimensions. Okay. So last page here, we would like to pause and take a look at them and figure out why they're misleading before I go through the examples here. Now would be a good time to pause. So we are going to explain why these 3 graphs are misleading and how we could improve it. We got burglaries in Minneapolis, this horizontal bar graph. This top bar lists July to August, and then all the other months down here. Okay, so problem is July and August are only 2 months of the year. The other months, this is the remaining 10 months. So these are not evenly distributed. So option 1 is I go month by month. So each month gets its own box. Or I could do it in groups of 2. Group 2 months at a time. Okay, the goal here is to truly show that summer months have higher burglaries, but we have to make sure that it's broken correctly. Okay, so maybe in January there's this many, in January and February, March and April, May and June, July and August. And then all these other ones are going to be relatively small because this is all combined together to make this last 8% here. Make sure no matter which scale you're looking at, both sides are even. So this side is not an even breakup, so it is misleading. All right, B, I'm pretty sure this is actually the same. Is this the same one we looked at back here? Number in poverty, I think it is. Because we didn't actually discuss the correct way to fix it, we have to make sure that we start at 0. That has to have a 0 there. 30, let's try to figure this out here. Let's see if I can make it work on this page. You could see what it would be. So 25, 20, 15, 10, 5, 0. And I know I'm going over the other graph right now, but just to give you an idea of the way that this graph would look had I done it correctly here. Okay, so because this is where my 0 is, 25, 20, 15, 10, 5, 0. You can see then that from here over to here is not as big of a difference as this original graph made me see from just looking from here. Okay. I'm going to have to erase it to be able to see this here. All right, last one here. How we flush a public toilet. 41% uses a shoe, 30% acts normally, so just normal like hand flush, and 17% uses a paper towel. All right, so first problem. No scale at all. There is no representation to see that 41 is up here and why is 17 up here? That there is no scale. Okay, second thing, if I add 41, 30, and 17, one that makes 8, 70, 80. That's 88%. Where is the last 12%? Where's that leftover data? What are you doing to flush the toilet? This is not all of the data. Okay, so how would I fix this? Well, I would create a scale and actually have, 10, 20, 30, 40, so that I could draw for my shoe, for my normal, for my paper towel, but then I need whatever this extra piece is. What is that? Where's my data? Okay, if I'm doing percentages, those better add up to 100%. So you should be able to, at this point, go and look at any graph that you're given and see. I'm looking at this now. This doesn't make sense either. We only have 28% of our data here. Where's the rest? So only 28% of our burglaries are accounted for. That does not make any sense. So percentages should always add up to 100. We should always have zeros. We should always have even scaling. We should always have two-dimensional flat graphs. Well, like I said, hopefully now if you come across a graph, you can at least look at it really quickly and say, hey, that's a good graph, or hey, that's not. This is wrong, and they're trying to tell me they're trying to skew my view, and they're not gonna get me. So one of the things you're gonna do this chapter is actually go to Google and find a bad graph, okay? They're all over, and I want you to be able to look at it and tell me what's wrong with it and how you could fix it. Okay, so this is the end of chapter 2. I hope this was a little bit more involved, kind of fun, working with graphs. This is your first real attempt with working with StatCrunch. So if you get hung up on creating any of the graphs, remember you can go back and view the other videos. You can go straight in the Pearson or StatCrunch website, and you can find videos of how to create just a specific graph. Like, hey, I need to do a bar graph. You could also just Google it. Hey, how do I make a bar graph in StatCrunch? And you'll find videos right there. So hopefully, like I said, that will help you if you get stuck on remembering how to create a certain graph. There's always those review documents in there to help you as well. And as always, please email me with any questions you have, and I will see you next week for chapter 3.